the part of set theory. So on the other day we were discussing regarding sets, introduction to sets, the various types of sets like finite set, infinite set, singleton set. We have discussed about all these things. At the same time we have discussed about the operations which can be done with the help of sets, so called as union of the sets, intersection of the sets, and subtraction. So those are the three operations which are possible with the help of sets. And at the same time we also discussed about universal set, right? And also we explained about what is mean by a subset, what is a superset. So now let us understand about the three forms, so called as, about three different forms what we have discussed in the last class, that is regarding the expression of sets, like using of descriptive form, so just describing the elements of the set with the help of a statement. And at the same time we have also used one more method, one more model called as set builder form, which is depending on the condition, based on what condition the set has been formed. That is what we're going to use it as set builder form. And set builder form is also a short form of the total set. Even a biggest set can be written in a simple way with the help of the condition. And then third method is it is about using a roster form. So roster means write down all the elements, or whatever it is, maybe in English alphabet or numbers. Generally we take these two as elements of a set. So we're going to write down all the possible elements in that particular set, right? It may be any number. So likewise we're going to write these three methods writing the set. So one is descriptive set, descriptive form, number two is set builder form, number three is roster form. So generally we come across these two, called as set builder form. If you know set builder form, we can write down its roster form. That means we can find out elements of that particular set. Okay, now in this session let us understand how to solve the problems. Whenever here you can see the set builder form is given. We are supposed to write down the elements of that particular set. Now here we assume that there is something called a set called A1 here. A1 in flower brackets are putting x such that 2x plus 3 is equals to 11. Now the condition is 2x plus 3 is equals to 11. So whichever that satisfies this equation is going to be the elements in that particular set. Sometimes it may be a singleton set, and if there is no element is possible, then what we'll say, it is an empty set or null set. Now you take 2x plus 3 is equals to 11. It is a set here. So let us just send this 3 to the RHS. Then 2x is equals to 11 minus 3. Then 2x is 8 and x is equals to 8 by 2, that is x is equals to 4. So now x is equals to 4, that means you can have only one element that is present in this set. Now this set is consisting of a single element, that's why it is a singleton set. Now you can write the set like this. So now writing the tabular form or roster form, a1 is equals to, put in the flower brackets, we're going to have 4 as element, so a1 is equals to 4. Right, now let us move to the second problem here. A2 is equals to x such that x square minus 4x minus 5 is equals to 0. Here also there is a possibility of getting one or two elements, and it all depends on the solution of that equation. So here x square minus 4x minus 5 is equals to 0. Now let us write down 5 as can we write 5 as 5 into 1 you can write, and there is a minus here. So minus 5 means when you multiply it, minus into plus we should write. So minus 5 into plus 1, minus 5 into plus 1. So x square, in place of minus 4x we are writing minus 5x plus x minus 5. So taking x as a common factor in the first two terms, we are going to have x into x minus 5 plus 1 into x minus 5. So x minus 5 into x plus 1, what we are going to get. So now x minus 5 into x plus 1, these are the two factors for that particular equation. Now writing it, finding out the values of x here. So you can take x minus 5 is equals to 0, then x is equals to 5. If you take x plus 1 is equals to 0, then x is equals to minus 1. So there are two values what we have, possible values for this particular equation. So these are two called as solution for the equation. So x is equals to 5 and x is equals to minus 1. So a2 we can write it as 5 comma minus 1. So here it may be a negative integer what we have got here. So there are two elements in this. The two elements are 5 and minus 1. Now let us take the third one. So a3 is equals to x such that x belongs to z. Z means it may be any integer, either it may be positive or negative, and it also includes 0. Right, we know that 0, positive integers and negative integers all combined it as integer z, and 0 is not belongs to either positive or negative integer. So let us take the condition here, minus 3 less than or equals to x less than 4. So you can see the difference here, less than or equals to means it should include minus 3, and less than 4 means it should not include 4, it should be less than 4. That is how we should write the elements here. So if you take this condition here, there are two conditions. It should be more than minus 3, 3 and minus 3 more than minus 3, and it should be less than 4. So then we'll write down all the positive integers and as well as negative and 0 here. So now we should write down the tabular form or roster form here. Writing the tabular form, so we can start like this: minus 3 and minus 2, next highest is minus 2, next minus 1, next is 0 and 1 2 3. We are not going to include 4 here. So these are the elements here. So how many elements are there? There are 7 elements that can be taken into this set. So what is the cardinal number of this set? We can say 7 is the cardinal number. 7 is the cardinal number of this given set. Now you take next problem here. X is a 2-digit number and sum of digits of x is 7. So what is that condition here is, it should be a 2-digit number and sum of the digits. That means if you take, let us say 16, now 1 6 is what? 1 plus 6. So there are 2 digits here. 1 plus 6 is 7. So the total of the digits is 7. So likewise you can take 2-digit number as 1 6. Now let us take here, therefore you can take 2-digit numbers and which will have the sum as 7. So you can write down from let us say 0 to 10, it's not possible. Then 2-digit number, so that's why you cannot write like, and then more than 10 we should take. So it will be 16. That means 1 plus 6 should be 7. Then in from 20 to 30 you're going to have 25, and from 30 to 40 we're going to have 34. So that 3 plus 4 is 7. From 40 to 50 we got 4 3, that is 43. From 50 to 60 you can write 52. From 60 to 70 61. From 70 to 80 you can write 70. So 0 7 is 7, but 70 is having value here. So now how many elements are there? There are 7 elements, 7 possible such numbers we can write, where the sum of those 2 digits should be 7 and it should be 2-digit number. So likewise we can find the solution for this set builder form. So likewise if you take set builder form, we can write the tabular form or roster form. Now you take this fifth problem here. X is such that x is equals to 4n. We are writing 4n means 4 into n. N is some variable, so called as n belongs to w. W means it is a whole number. Whole numbers actually starts from, you should assume that a whole number starts from 0. You should not forget that. So 0, and n should be less than 4. N should be less than 4. So whatever the possible values we are substituting here, it should be less than 4 means only up to 3 we should take. So starting number, we know that because it is a whole number, you should start from 0. Imagine if it is a natural number, you should start from 1. So now substituting the value here, x is equals to 4n. In x is equals to 4n, we have to substitute the values. First we should substitute n is equals to 0 because n belongs to w. So whole number starts from 0. So let us substitute the value. So x is equals to 4n. 4n means 4 into n. 4 into 0. So 4 into 0 is 0. So now next number is 1 we have to take, because after 0 this is next number is 1. So 4 into 1 is 4. So after that then we are going to have 4 into 2. Then 4 into 3. We have to stop to this point because the condition is n less than 4. So we have to start from 0 until 3 we have to take it. So the values are 0, 4, 8 and 12. You can see that this is how we can write the constructive, or you can say tabular form. So this set builder form actually gives the condition, and based on the condition or formula we have to substitute by taking the formula as well as the condition into consideration. Next, so I hope you understood this problem. Next problem, then going to the next one, it is a. So you are taking one more set here. A is equals to x such that x is equals to n by n plus 2. So you can assume that n is here, it is given as natural numbers. So it belongs to n, capital N, natural number. So we know that natural number starts from 1 to infinity. So all positive numbers are going to be natural numbers here, positive integers. Next, n should be greater than 5. So the one more condition what they have given is n should be greater than 5. So if you take n value, n should be greater than 5. So we have to start from 6 7 like that, because you should not take 5 into consideration, because the condition is saying about only n greater than 5. If it is n greater than or equals to 5, then we should assume that we have to take 5 into consideration. Now let us take the formula here. X is equals to n by n plus 2. Now if you take n value as 6, now n is equals to 6, you can take x is equals to, so now substituting the value of 6 by 6 plus 2. So 6 by 6 plus 2 is 6 by 8, that is 3 by 4. Then n, substitute the value of n as 7 here, 7 by 7 plus 2. So x will be 7 by 9. If you substitute n value as 8, so 8 by 8 plus 2, that is 8 by 10. Obviously it is 4 by 5. So we can simplify it, or else we can can keep it as it is. So when n is equals to 9, assume that n is 9, and 9 by 9 plus 2, that is 9 by 11. So likewise it is an infinite set, because when you say that it is a n greater than 5 means we should take taking the values of n more than 5, and we haven't mentioned anything called upper limit here. So that's why it is a finite set. It is an infinite set. So whenever there is an upper limit, so called as a closed boundary, then we call it as a finite set. Here there is no such boundary here, because we can keep on writing the values of n continuously. So that's the reason why here it is an infinite set. So we can write like this. So when we have substituted n6, that is first element, because it has to be more than 5. So 3 by 4, 7 by 9, 4 by 5, 9 by 11, and so on. And you may say that you may get some infinite number of such elements which may fulfill the above condition. So likewise you can write down the tabular, or you can say this is as a roster form. Right, next let us move to the second question here. Let us write down in the reverse way, that is whatever the elements that are given like tabular form or roster form, we should write down this in set builder form. That means by seeing the values, the numbers in that particular or elements of that set, we have to write down the condition, and this condition has to fulfill the set. Now take the first problem here. B1 we are assuming here, B1 is set here 6, 9, 12, 15 and so on. Now if you see these elements, you can understand the difference between the elements. What is the difference between the elements here? So 6 after 6, 9 we got, 9 after 12, that is 12 after 15. That means there are 3 such difference that we can see between the elements. So now we can assume that there is a variable called x such that x is equals to, now let us take here 6 is found like this. Now 6, because as it is, you know that natural numbers will start from 1, 2, 3, 4, so better to have a condition like this. So if you write 6 as 6 can be written as 3 into 1 plus 3 into 1 plus 3. So in place of 1 we write n here, so that the condition will fulfill. Now 3 into 1 plus 3, that is 3 plus 3, that is 6. Now if I take n as 2, then 3 into 2 plus 3, that is 6 plus 3 is 9. So likewise we are going to get all the elements. So, and one more thing is, it is infinite set. So as it is infinite set, you need not to stop to at any condition. So then we will write like this, x such that x is equals to, now 3n plus 3, I am writing it as 3n plus 3, because this condition is actually giving the results called 6, 9, 12 and 15. So 3n plus 3 I am writing here, and n belongs to capital N belongs to capital N. That means n is a natural number. So n is a natural number. So you can write the condition like this, x is equals to 3n plus 3, x is equals to 3n plus 3, and n belongs to capital N. Then B2 is equals to 11, 13, 17, 19. Let us take one more problem here, but it is a finite set. Reason is the elements are being fixed within the given boundary. So you can write like this. So here 11, 13, 17, 19, and we can see that they are all, you can see that by seeing them, you can see the characteristic of them. So let us say 11 is a prime number as well as odd number, 13 is prime number and odd number, 15 odd number is missing, so definitely this is not belongs to odd number set. Then 17 is odd number as well as prime number, 19 is odd number as well as prime number, and all these, let us say between 10 to 20, you can see these are the 4 prime numbers that are existing. So all these 4 prime numbers, all these 4 prime numbers indicates that they are being existing between 10 to 20. So you can write like the set builder form. So x is such that x is a prime number between 10 to 10 and 20. So we are telling 10 and 20. Between means we should not take 10 and 20. And anyhow 10 and 20 are not prime numbers. So that is not the condition here. So we can write this like this. Okay. So it looks like as if it is a descriptive statement, but not this. It is a condition what we have written. So x is a prime number between 10 and 20. Now let us take one more set here. Set 1 by 3, 3 by 5, 5 by 7, 7 by 9, 9 by 11 and so on. So now by seeing this, what we have to understand is the value what we have got on the at this denominator is becoming in the numerator in the next fraction. So that is repeated here. So let us say first fraction, if we take 1 by 3, there 3 is the denominator, then 3 has become the numerator in the next fraction. Likewise 5 we can see that, and imagine this will be continued for the infinite series. Now let us write down here. So if I take here 1 by 3 means 1 by 1 plus 2 we can write 1 by 1 plus 2. So 3 can can be written as 1 by 1 plus 2, so that you can write like this: x such that x is equals to n by n plus 2, n by n plus 2, where n is an odd natural number, n is an odd natural number. So here assume that n belongs to n, n is an odd natural number they told. So odd natural number means n belongs to n belongs to n. We can go on writing, for example, so if I take 1 here in place of n, I am taking 1 here, so 1 by 1 plus 2, so first value is 1 by 3. So if I substitute value of n as 2, then 2 by 2 plus 2, that is 2 by we can write like this, so here 3 by, so what is the result we got here? So 3 is the result what we got, so n value, so 3 by 3 plus 2, then 5 by 5 plus 2. So likewise you can write down all the values or elements of that particular set. Now let us take one more problem here. So you can see here b4 is equals to 8, 27, 64, 125 and 216. So if you see the individual elements, they are all looking like cubes, right? You can write it as a cube. So x is such that x is equals to, you can write n cube, so because n value we know that, so n cube, so that n belongs to n. And how these n values are varying? So it is 2 cube, what is means 8, so it is starting with 2 and ending with 6, that is 6 cube is 216. So likewise these are only cubes from 2 to 6, from 2 to 6, so 2, 3, 4, 5, 6 we have written. So you can write like this. So x is such that x is equals to n cube, you are writing n cube, and n belongs to capital N, n belongs to capital N, and 2 less than or equals to n less than or equals to 6 we are writing. So that you can write like this. So 2 cube, 3 cube, 4 cube, 5 cube and 6 cube. So 2 less than or equals to n less than or equals to 6, that is has to be the condition. And here the rule what we have written is n cube, we have written it as x is equals to n cube, and this n indicates the formula here, n is belongs to capital N. And one more thing is these values of n should be between 2 and 6, sorry, should include 2 and till 6 we are writing. So that's why we are writing it as 2 less than or equals to n less than or equals to 6. Okay, so let us take this fifth problem. You can see the negative integers here, so minus 5, minus 4, minus 3, minus 2 and minus 1. So x is such that x belongs to z we are writing, because it is a negative integer. And how these values are there? The values including minus 5 to minus 1. So you can write like this: minus 5 less than or equals to x less than or equals to minus 1. So it has to include minus 5 and minus 1, as well as between those values also we have to include. So that's why we can write the set builder form like this. Next b6 is up to infinity to minus 6, minus 3, 0, 3, 6 and so on. So you can see 3, 6 means it is multiples of 3, 3 1s are 3, 3 2s are 6 likewise. And it is one more thing is we are taking it is all negative and positive and all the integers. So we can write, so it has to include 0 also. So you can write x such that x is equals to 3n we are writing. X is equals to 3n. 3n means 3 into n. N here is natural number, sorry, 3n. N is all integers you have to take. So first thing is 3 into 1, that is 3 1s are 3. So first 0 it takes z as it know, and it also going to include negative values. So when you take n as minus 1, so you are going to get minus 3. If you take n as minus 2, you are going to get minus 6. Likewise you are going to get infinite number to the left and infinite number to the right, so that it is what, it's not it is unbounded set here. That's why it is infinite set, we call it as infinite set. So that is how we are going to solve these problems. Okay, so we'll meet in the next class. Thank you.